So inverse Laplace or Laplace can be quite difficult, but if you learn how to do shifting, it can make it much easier. So just a quick reminder what inverse Laplace is when you have something in the Laplacian domain, so in terms of s, you want to convert it back into the time domains in terms of t. For example, you can see this easily on your formula booklet, that if you have 1 over s squared, the inverse Laplace, which is usually done like this, becomes just t. So this may look confusing because there's a lot of different letters, but we'll go through a few examples and we'll show you how they can be make solving these much easier. So example 1. So if we have a function where we have 1 over s minus 2 squared, and we want to do the inverse Laplace of this to get something in terms of t, well, usually what you would do is you probably want to do some kind of partial fractions, but by doing what I'm about to show you with shifting, we don't have to do those anymore. So we want to do the inverse Laplace of 1 over s minus 2 squared. Remember, shifting, we can take out this 2 and essentially just write it as e to the power of 2t. You can think of it as kind of we're shifting all the s values by plus 2. So then this just becomes 1 over s squared. So we have e to the power of 2t on the side. And we want to do, now all we have to do is the inverse Laplace of 1 over s squared. And this can be very easily seen using the formula booklet. And we also actually saw it earlier. 1 over s squared is t. So it's e to the power of 2t times it by t. So second example, we have a function in terms of s. 2s plus 1 divided by s squared plus 4s plus 13. Now normally when you have a function like this, we want to kind of factorize this denominator and then do partial fractions. If you try to do that with this, it doesn't really give us two clean sets of brackets. And instead we have to do completing the square. So this s squared plus 4s plus 13 becomes s plus 2 squared plus 9. Now if we want to do the inverse Laplace of this, so this denominator is still pretty hard to work with, but by shifting all these s values by minus 2, we can convert this denominator into s squared plus 9. So remember, we have to kind of take out an e to the power of minus 2t, and now this becomes the inverse Laplace of t, s minus 2 plus 1 over s squared plus 9. Remember, if we shift this value, s value, you have to do it for all the s values. So this becomes s minus 2. This is s plus 2 minus 2, so it's just s. So s squared plus 9. Then we can simplify this out. Remember, this e to the power minus 2 just remains untouched on the outside. Then we split it into separate fractions. And then using the formula booklet, we can convert the inverse Laplace of s over s squared plus 9 and of 3 over s squared plus 9 into cos 3t into sine 3t. And this gives us the answer very neatly over here.